Hi, I'm Andreas Schiele, the PI of the Interact experiment, and I'm going to give you an introduction to the ground robotics setup for Interact. In Interact, for the very first time, an astronaut will control this robotic vehicle from space in real time to do a mechanical assembly task on a planetary surface. So the astronaut will be tasked to insert a peg, or let's say a simple form of a connector, into a task board, which is a task that is very difficult to do with vision information alone, because this peg and the task board has a tolerance of only 150 micrometers. So the robotic system that we are using for this insertion task has to be compliant and be able to transmit the sense of touch. And you can see this robotic system here complies to external forces. It will relay those force informations through a satellite link to the International Space Station, where the crew member will retrieve force feedback on a joystick and retrieve real-time video on a tablet PC. The link will go through the Tetris communication system, which is at an altitude of 36,000 kilometers in orbit. The task of the crew member will be to drive this robot to find the task board and to retrieve the peg and insert it here for the very first time. So ESA will lead the way in doing remote assembly on planetary surfaces for the future of spaceflight. Let me take you through the individual technical systems of our Interact Centaur that we'll be using for our Interact space experiment in September. So Interact Centaur has a mobile platform that is rough terrain compatible. It has 4 wheels and 4-wheel steering. So Interact can go forward, backward, and you will be able to command it in increments of 10 centimeters, 50 centimeters and 1 meter, and it can do spot turns, and you will be able to command increments of 10 degrees, 45 degrees and 90 degree segments. So the Interact Centaur has multiple camera systems which you can select from. It has the driving camera on top of the vehicle, which is located on a pan-tilt unit, actually a robot arm, that allows you to pan and tilt the camera before you drive. You have a front HazCam between the wheels and a back HazCam behind the vehicle, which allows you to see the shaded areas that you can't see through the main driving camera. On the robotic arm you have a tool camera, which actually brings a close-up view of the tool and the peg and the task board. Once you're near to the task board for the insertion, you're free to select that one. The robotic arms of the platform are 2 KUKA lightweight robots that are controlled in impedance control mode, which means they can be compliant to the environment and relay contact forces in very high fidelity to your force feedback joystick. The robot arms comply to external forces. They're equipped with Cartesian force torque sensors, with a gripper, and they're holding the peg. And we instrumented the peg with a laser that actually allows you to give information on spatial depth in a monoscopic stereo view. So when you're closing in on the task board, by looking at the laser spot on the surface, you'll be able to confirm whether the peg is well aligned to the hole or not.